Now that we know what is train test split as well as cross validation, let us compare these two techniques together. What are the advantages of cross validation? It's a more accurate estimate of out of sample accuracy and makes more efficient use of data. That is, every observation is used for both training and testing. The advantages of train test split being runs k times faster than k-fold cross validation. So if you're going to set your k-fold cross validation to be 5, your cross validation technique is going to be 5 times slower than your train test split. It's simpler to examine the detailed results of the testing process. So whatever you're going to observe in train test split, you're going to have to observe 5 times over in k-fold cross validation, which kind of poses quite a bit of manual analytical problem. So in situations where you can think of being stingy with the accuracy, please do go ahead with the cross validation and spend more time evaluating your models. So what are some of the cross validation recommendations? K can be any number, but k equal to 10 is generally recommended. And this again, the value of k depends upon the domain you belong to, the size of your dataset, all of these things. For classification problems, stratified sampling is recommended for creating the folds. So each response class should be represented with equal proportions in each of the k folds. This is very important. Scikit-learn's cross-val score function does this by default. So what do I mean by this? Let's say we have a data set where we have 100 observations, out of which 80 observations are of class type A and the rest of the 20 are of class type B. Now if we do a train test split or a cross validation that we have been doing like this, there is a chance that class type B may not be seen in the test data or may not or be very sparse in the training data. There are chances where there can be scenarios with respect to that. To avoid this, we need to make sure that each of the classes that are present in my classification dataset are present in equal proportions, no matter how many splits I create. Scikit-learn's cross-val score function ensures this by default. So recommendation number 1, go ahead with k equal to 10 if you have a decent sized data set and use stratified sampling for creating the folds on a classification data set. Another cross-validation application is model selection. So the goal here is to compare the best model, the best KNN model with logistic regression on the IRIS dataset. So the k nearest neighbors classifier is another classification algorithm. It is out of scope for this course. We will definitely take it up in some of the advanced modules that we will cover, which won't be part of this course. But in a sense, k nearest neighbors classifier is a classification algorithm just like logistic regression, which when fed some data, it gives us back its predictions, and we want to know k nearest neighbors classification at that level only. Interested people, of course, I'll include some learning resources so that you can go check it out on your own. But for the purposes of discussing cross-validation, we just needed another classification algorithm so that we can compare it with logistic regression. The goal is not to understand what KNN does internally. So having imported the k neighbors classifier, we are going to set the neighbors equal to 20 and print the cross validation score. There we go. It gives us a 98% accuracy. Now using the same technique, k-fold cross validation with logistic regression gives us a 95% accuracies. And now you can clearly see that for this data set, k nearest neighbors is a better model, is outperforming our logistic regression model when it comes to the IRIS data set. So the cross validation is a technique that can be used as a means to selecting appropriate models if you have a bunch of models to compare it with. Cross validation can also be used for feature selection. So the goal here is to select whether the newspaper feature should be included in the linear regression model on the advertising dataset. So if you go back to our linear regression example on the advertising dataset, you will remember that we were trying to determine what the sales will be using linear regression. For features, we were using TV, radio, newspapers, and for selecting those features, we were using techniques like p-values. Let us see how cross-validation can further help us. So we are going to get our inputs out of the way, download our data, read it through pandas, select our features, encode X and Y, and then do a linear regression with a cross-validation and print the scores for each of those iterations. So you see that some of the scores outperform some of the other scores, which clearly indicates that doing one single train test split might not be enough. Now let us quickly fix the sign of these mean squared errors. So this is what we get. And if we want RMSE, or the root mean squared errors from the MSE, we take the square root, and then finally we take the mean, which comes to 1.69. So in a sense, if we exclude newspaper and then repeat the whole exercise, we get an RMSE of 1.67, which seems to be better than using TV, radio, newspaper altogether. So again, this is another technique with which we were able to eliminate the newspaper variable.